Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 3.3 entitled Solving Multi-Step Equations. And today's goals are going to be to solve two-step linear equations. We might actually solve some three-step equations as well, but basically just multi-step equations. So the multi-step equations for now are just going to have three steps in them. And then we're also going to write and solve two-step linear equations that model a word problem. And then we also are going to solve some multi-step equations that have decimals. Now, when we're solving a multi-step equation, we have to remember our order of operations. And we especially have to focus on the last two steps, the adding and the subtracting, and the multiplying and the dividing. And that's basically what we're going to undo as we solve a multi-step equation. So first we're going to undo addition and subtraction. So you kind of start at the end of the order of operations and you work backwards. So you undo addition and subtraction first, then you undo multiplication and division. So in example 1, here we have 4 two-step equations. And again, you want to make sure that you show all of your work. Okay, you've been showing your work for the one-step equations that we've done in the previous two lessons. Now you're just going to be combining those two concepts together. So in part A, we have 2x plus 7 equals 127. So you can still put a little box around your x or your variable so you know that that's what you have to isolate. And now, instead of having one thing that you have to get away from the x, there's going to be two things that you have to get away. And those things are going to be mathematical operations, and they're either going to be addition and subtraction or multiplication and division. In part A here, we have a plus 7, and we have a times by 2 that are happening to the x that I put in the box. And if we're undoing our order of operations, we have to subtract the 7 first. We have to undo the addition or the subtraction. Now, sometimes students want to subtract the 7 from the 2x. They like to subtract the 7 from every single thing that they see. But remember, what you do to one side of the equation, you do to the other side of the equation. So if I subtract 7 on the left side, I don't have to put another subtract 7 under the 2x because he's still on the left side of the equation. So just write it one time on this side and one time on the right side under the 127. So now I'm going to bring down my 2x. The 7 and the 7's cancel. And 127 minus 7 is 120. So now I've undone that first step, and now I have one step left. So this is just like what we did the day before. I can still keep that box around the variable if I'd like to, but now I have a 2 times x equals 120. To undo that multiplication, I divide. And what I do to one side, I have to do to the other. So x equals 60. And again, we could check our work. 2 times 60 is 120, plus 7 is 127. For part B, I still have multiplication, and I still have addition. I have negative 7x plus 32 equals negative 21. So this time I'm going to be using a little more of my positive and negative number skills here. I can still put a box around the 7, or I'm sorry, around the x. That's what I'm going to be solving for. And I do have addition. I have a plus 32 that I have to get rid of. And I have a timesing by a negative 7. Now don't confuse that negative in front of the 7 as a subtraction. It's a negative 7 and it's being multiplied by the x. So my first step is going to be to subtract the 32. That's the addition that I want to undo. So I'm going to bring down my negative 7 times x. The 32's cancel. And then I'm at negative 21 and I'm going down 32 more, so that's going to be a negative 53. So when you have two numbers that are both negative, you can add them together and then keep the sign. So now I still have this x that I'm trying to isolate. I can still put a box around it again if I'd like to. And my last step now is to undo that multiplication or division. In this case, I have a multiplication that I'm going to undo by dividing. So negative 7 divided by negative 7, those cancel. So I get the x isolated. And when I divided by the negative 7 on the left side, I also had to divide by the negative 7 on the right side of the equation. However, negative 53 is not evenly divisible by negative 7. So I'm going to get a decimal for my answer here. Negative divided by negative is a positive, and we're going to round our decimal to 2 places if it's not already 2 places on the calculator. So in tonight's homework, you might have some answers to your problems that are whole numbers, and you might have some that are fractions or decimals. That's okay. Your answer's not wrong if you get a fraction or a decimal. In part C and part D, now I've got subtraction and division. And actually, for part C, I can rewrite this a little bit first. I have this plus a negative 4. So if I wanted to rewrite this problem, instead of having a plus and negative, I could just put minus 4 equals 5. Now that helps me see that to get rid of this minus 4, I have to add 4 to both sides. So I still have my y divided by 3. The negative 4 and the plus 4 cancel, and 5 plus 4 is 9. Now the y is what I'm solving for. It's what I'm trying to isolate. My last step here, I have y being divided by 3. So to undo that, I have to multiply both sides of the equation by 3. So those 3's cancel, and I get the y all by itself. And 9 times 3 is 27. Now notice I did that problem without boxing in the variable at all. So remember, you don't have to box in the variable. You can if it helps you to see what you're solving for. Last one here for part D, I have 3 halves times x minus 2 equals 7. So the first thing I'm going to undo is that is that subtracting 2, and I'm going to undo that by adding 2 to both sides. Okay, here again, here's my x I'm trying to isolate. So I'm going to have 3 halves x that I bring down. The minus 2 and the plus 2 cancel each other out, and the 7 plus 2 is 9. Now I'm trying to solve for the x, and it's being multiplied by a 3 halves. So the opposite of multiplication is division, but I don't want to divide by a fraction. I want to multiply by the reciprocal. So those fractions cancel on that side. And I can multiply across. So I get 18 over 3, which is 6. Or I could cancel the 9 into the 3. And then 3 times 2 is 6. So this is the work that we should see for every problem that you're doing on your homework. If I'm putting this much work into the notes, you need to be putting the same amount of work into your homework. Show every step. And when we're solving 3-step equations, you're going to have one extra step first before we undo the addition and subtraction and then undo the multiplication and division. And that new step is going to be to either distribute or multiply by the reciprocal. Now, as we look at these problems, we'll get to see the difference between when we should distribute and when we should multiply by the reciprocal. Usually, if you have a whole number, like you do in part A and part B, you want to distribute that whole number. You could divide it out first, but we want to still practice those distribution skills, okay? But in part C and part D, you have a fraction that's being distributed. And sometimes when you distribute fractions, it's really, really messy. It creates more opportunities for mistakes. So a better way to handle those problems is to multiply by the reciprocal and get the fraction out of there, okay? So if we go back to part A, I have 2 times the quantity x plus 4 equals 20. So I'm going to distribute the 2 to the x and to the 4 first. I'm not going to distribute it to the 20 because the 20 is on the other side of the equal sign. He's not inside the parentheses. So I actually have 2x plus 8 equals 20. Now I've done that new first step, and I can continue with my other 2 steps that we were practicing in the previous example. So I'm going to undo my addition or subtraction next. I have adding 8, so I'm going to do that by subtracting 8. Bring down my 2x. The 8 and the negative 8 cancel. And 20 minus 8 is 12. Then I have to undo this multiplying of 2, so I'm going to divide by 2. And those 2's cancel. Now I have the x isolated, and x is equal to 6. Now the other way to do this problem, we had 2 times x plus 4 equals 20. The other way you could still correctly do this problem is divide by the 2 first. So those cancel, and then you have your x plus 4 equals 10. And then you could subtract 4 from the x and from the 10, and you would get x equals 6. So that is another completely correct way to do the problem. Instead of distributing, you're dividing by that number out front. But again, we want you to practice those distribution skills from chapter 1. So we're just going to say that the best way to do this problem is to distribute first. So for part B, we're going to distribute the negative 4 to the x and the minus 2. So negative 4 times x is going to be negative 4x. And then negative 4 times a negative 2 is going to be a plus 8. Now you could also think of it as a negative 4 times a positive 2, which is a negative 8, and then you're minusing a negative 8, which is like adding 8. Either way you want to think about that distribution. So now I've done that new first step where I have to distribute. Now I can undo my addition and subtraction. So I'm going to undo that adding 8 by subtracting 8. It's just coincidence that in the last example, we also had to subtract 8 as our first step. That's just coincidence. And then next, I'm going to undo my multiplication with division. So I'm going to divide by the number that's being multiplied by the x, divide by that negative 4, and we're going to get a negative 1. Now again, you could do this problem by dividing by that negative 4 first. So if you divide by the negative 4 and divide by the negative 4, then you get x minus 2 equals negative 3. And then you can add the 2 to both sides, and then you'll get x equals negative 1. So that is, again, another completely correct way to solve this problem, but we want you to practice those distribution skills so you get really, really good at them. Okay, now for part C and part D, we really want to get rid of those fractions out front of the parentheses first. And the main reason is because if I try and distribute that 1/2 to the x, that's not a problem. 1/2 x is just 1/2 x. But if I try and take half of 3, that's not a nice whole number. I still get a fraction. I get 3 halves. And then I'd have to add the 3 halves to the 7. Ugh, it's going to get messy. I'm going to be dealing with a lot of fractions. I'm going to increase my chances of making a mistake. So the most straightforward way to deal with this problem is to multiply by the reciprocal of that fraction. And remember, it's kind of like what I did up here in the little purple bubbles. I had a 2 out front of the parentheses in part A, so it was 2 times whatever was in the parentheses, so I divided. And that's the same thing that's happening here. I have a 1/2 times the stuff in the parentheses. So I want to divide by the 1/2, but I don't divide by a fraction. I multiply by the reciprocal. So I'm going to multiply by a 2 over 1. And what I do to one side of the equation, I have to do to the other. Again, you don't have to multiply the 2 to the x or the minus 3. It's just the whole left side and the whole right side of the equation. Now, the nice thing about the 2 and the 1/2 is that they cancel, so that x minus 3 kind of pops out of those little parentheses. And then 7 times 2 is going to be 14. So now I have a one-step equation. I just have to add the 3 over so I know what the x is going to be. By adding the 3, I undo that subtracting 3. I get 17. Okay, so make sure you show your work for each step. And for part D, do this in green. It's written backwards, basically from example C. But that's okay. It's still the same process. I still have a fraction that wants to be distributed to the x and the 2. But if I distribute it to the x, that's okay. I get 3/10 x. It's not as nice as the 1/2 x. But if I distribute the 3/10 to the 2, I'm going to get 6/10. And then I have to subtract the 6/10 from the 12. So we're going to try and avoid those fractions whenever possible. So instead of doing all that distributing with the fraction, I'm going to divide by 3/10. Okay, this is multiplication going on between the parentheses and the fraction. So I want to do division to undo it. But remember, we don't divide by a fraction, we multiply by the reciprocal. And I'm a little short for space on the inside here, so I'm just going to multiply over here, 10 over 3. I'll write it here, times 10 over 3, and I know I'm writing over the d there. Okay, so I have 10 over 3 times 12 over 1. And then over here on my right-hand side of the equation, when I multiply by that reciprocal, everything cancels. So I get the x plus 2. Now, on the left side, I could cancel a little bit. I could multiply across and get 120 divided by 3. Or I could say that the 3 goes into the 12 4 times. And now 10 times 4 is 40. And now I have one step left to solve for the x. I have to undo that addition by subtracting the 2. So those cancel. X equals 38. So again, make sure you're multiplying by the reciprocal, especially when you have a fraction. Now, if the fraction will distribute nicely and it kind of works itself out, meaning that it multiplies so that you end up getting a whole number as an answer after you distribute it, that's fine. You can distribute the fractions and get whole numbers. Sometimes that works. But when you go to distribute the fraction and you start getting more messy fractions, don't take that approach. Go back and multiply by the reciprocal so that those fractions work themselves out right away. So that way you're dealing with whole numbers as you go through the rest of the problem. You'll get the same answer either way. So tonight's homework has two parts to it actually. The first part is from section 3.3, and then this other section here at the bottom, this is from section 3.6. We're not actually going to do the section on 3.6 because it's the same type of multi-step equations, but your answers are decimals. Well, we did an example where you got a decimal for an answer. It's not any different than any of the other steps, so we're just going to combine a few of those problems in with your homework from tonight. If you have any questions, stop on by before school and see me.